All right, well, let's go ahead and kick off, guys. Thanks for joining us today. Appreciate everybody being here. My name is Hall Martin. I'm the CEO of 10 Capital. Today, we have a great presentation on generative models and the radiology department of the future. And leading us through this is going to be Bill Morrison of Trace Orthopedics. And with that, I'll have Bill introduce our speakers today, and then we'll go from there. Bill, thanks for joining us. Go ahead and kick us off here.
Yeah, thank you very much. And I'd like to thank 10 Capital for running this meeting. And I'm a co-founder and medical director of Trace Orthopedics, and we're sponsoring this event. So we have two terrific speakers. And with that, I'm going to get started and introduce Dr. Adam Zoga, who is a world famous radiologist who works with professional athletes. And with that, Adam, I want to get started. While he's loading up, if you have any questions about these lectures, please put them into the chat box.
Thanks, Hall and Shane and Bill and Adam for having me. Wasn't sure what kind of audience I'd have as far as knowledge of radiology, but just going to take 10 minutes and run through what a radiologist is and where I think radiologists will be going forward into the next decade or so. So I work at Jefferson with Bill Morrison. I've been here since 2002, and we've built quite a career together in imaging, the imaging subspecialty of musculoskeletal radiology. It's not the same as what you might think of from a radiologist sitting in a dark room, glaring at films covered with amalgam hung on a monitor. No, now it's a lot different. So there's a decrease in traditional diagnostic radiologists worldwide. Reimbursements for traditional diagnostic imaging studies are decreasing. There's an increasing demand for image-guided intervention, things like pain procedures, trigger point injections, things to help patients feel better on the spot with image-guided. Minimally invasive musculoskeletal reparative procedures are a hot commodity. And there's an increasing emphasis on quality of life for radiologists, and dovetailing on that, there's sort of a shortage of radiologists. At the same time, I don't know if any of you have tried to get an orthopedic surgery appointment recently, but it's tough to see a surgeon nowadays. You can see a PA, a nurse practitioner, and that's great, a non-operative person, but to get a surgeon to lay their hands on you is really difficult. So there's a greater need for image-guided pain interventions. And no, this was for if Simi went first. The machines have not yet taken over. So that's an ultrasound guided intervention on the top right side of the screen. We're injecting a shoulder there, and that's something we do all the time, every day here. Why are we short radiologists? Well, way back in 2017, the radiology chairs that were in power decided that we're going to need more interventional radiologists and less diagnostic radiologists, maybe because the machines were going to read the diagnostic imaging. And so they started a full new residency program for interventional radiology, the integrated interventional radiology residency. And that's just coming to fruition in 2023. So the downstream effect of that is we're training 20% less diagnostic radiologists than we used to. And these interventional radiologists are really, they're really targeted for vascular procedures and oncologic procedures, not sports medicine procedures. The American College of Radiology convened a commission in 2019 to predict the workforce, and they called for a need for an increased number of radiologists, but they way underestimated what has happened. Since the pandemic, the guardrails for imaging have been taken off, and there's a need for radiologists like we've never had. Sorry for the poor resolution of this image, but I thought it was a pretty telling image. This is the match results in radiologists, the unfilled match positions. You can see in 2015, the blurry 2015, that there were a lot of unfilled positions in the match, and now there are none. The red line is the interventional, and the blue line is the diagnostic. We're diagnostic radiologists, but we do interventions. So the match positions are filled, residents are going into radiologists. One of the reasons that there was a slowdown in the middle part of the last decade was cuts in Medicare reimbursement. But if you look at the cuts in Medicare reimbursement, really interventional radiology didn't get hit as much as most of the other subspecialties in medicine. In fact, an 8% cut with more efficiency actually leads to increased reimbursement and increased revenue. So interventional radiology and image-guided procedures are sort of hot. Simultaneously, look at orthopedic procedures over the same period, and arthroplasties went way up, but arthroscopy, so using a scope to get in a joint, went down. Well, why is that? My guess is it's because the reimbursement is so much better for arthroplasty. At the same time, imaging sort of say the same. So when you have a joint problem, you see an orthopedic surgeon, there's a decent chance they're going to recommend an arthroplasty. But arthroplasties can't fix things around the joint, like tendon tears and muscle tears. Are we getting paid less for our craft? Yeah, we are. But if we add value to the treatment plan consistently, and we advance further MSK imaging procedures, will continue to increase. And that includes subspecialty expertise, imaging tailored to pathologies, functional organized imaging reports, protecting our referrer colleagues from medical legal issues, avoiding added costs for dumb reasons, and offering image-guided therapeutics. So I really think that that's our future. What do we want our specialty to be? This was just from my capstone project when I went to business school, and the red 5-point diagram is what we were around 2010. Emphasis on speed and low cost. But to actually grow and prosper, we need to emphasize more on quality, flexibility, and dependability, availability and dependability. So 4V's diagram of what we used to be. Really low visibility, hiding in a room, high volume, variable variety. But what we want to be is visible, and we want to be patient facing, and we want to be involved in the healthcare team. Where do radiologists work in the US? This is from a consulting symposium, and it says that they work at all these different locations. But in reality, in 2023, radiologists either work for a corporation, a physician-owned consortium, which is tied to a corporation, a private practice, and those are rare, they're going away. They're all selling to the corporates. An academic practice, those are going away too. They're selling to the health systems, or a health system with an academic hub and cooperative partners. And that's where we work, and really that's where most of the radiologists are going to be in the next 10 years. Radiology practices are really hot targets. Since this white paper came out a few years ago, the selling of radiology practices has done nothing but skyrocket. And in fact, I saw 5 of the biggest radiology practices in London sold to corporates just this past month, right? So radiology practices are selling. Corporations and investment firms are buying radiology practices. Private equity is buying radiology practices. It's been a continued upward trend over the past 10 years. Some trends in radiology: IT development, aging population, all drive up imaging. Free access and research data sharing, that drives up imaging. But personalized medicine and precision medicine, I think, is the key one, where we can actually build a better specialty. Why are radiology practices consolidating and selling to corporations? Sort of a complicated slide, but these are some of the reasons I came up with, and certainly IT consolidation is one of them, like information systems across health systems. Difficulty showing value. When you're a small practice, it's hard to get good scores on the surveys and on the metrics that we use, HCAHPS and Press Ganey, and certainly peaking valuations by corporate suitors. Radiologists are burning out. They are listed as the second most burned out specialty in medicine right now. And why is that happening? So this is a paper in our literature just last year, and reasons for burnout were listed as lack of control, institutional cultures changing, work-life balance, excess stress, loss of meaning in medicine, unclear, constantly changing job expectations, and lack of social support. I don't know about that last one, but so we interviewed our own radiologists, our own orthopedists, and we sort of surveyed how orthopedists and sports medicine docs would like us to provide value-based service to a big practice. And we came up with this really complicated bar graph. But if you just look at the bottom, these are the different kinds of work we do: imaging centers, joint ventures, fee for service, per click reads, session space leash, boutique imaging, subspecialty consultation, and then altruism philanthropy. And what we want is we want the most bars to be high in each one. And boutique imaging services actually does really well. Radiologists tend to be happier when they're doing something that they're good at again and again and seeing patients along with the care team. Can we add value? This group from NYU did a great analysis of cost effectiveness of different imaging modalities. When you have a shoulder problem, you have many imaging options. When you have a shoulder problem, you have MRI, you have CAT scan or CT, and then you have ultrasound over here on the right. You have plain X-ray as well. And each has its positives and its negatives. But they did a nice analysis of who had the longest, the most quality adjusted life positive outcome, and who did the best 10 years out. And actually, by imaging alone, MRI and ultrasound were pretty even. However, when you add ultrasound with ultrasound guided intervention, patients were much happier 10 years out after they had one of these procedures. That led us to publish the evolving roles of MRI versus ultrasound in first-line imaging for rotator cuff tears. That's the most common injury of the shoulder. And sure, shoulder's complicated. This looks like, I'm sure, just shades of gray to most of you, but there's a little rotator cuff right here. There's a little rotator cuff tear. Rotator cuff's a complicated structure, and it's hard to image with any modality. But MRI is sort of restricted by non-3D imaging. It's plain selective. Ultrasound gives you 3D imaging. There's a complicated diagram of the rotator cuff that actually my 14-year-old daughter drew, and it shows how complicated the structure is, but any of these structures could be injured. So with ultrasound, we can target those things, and we were able to come up with an algorithm for imaging shoulder pain that we use across our health system, and it leads to where the patient might need to go for intervention and ultimate treatment. What can you do with intervention? Well, the postoperative, what happens when surgery fails? Surgery has failed here. There's an anchor that's sitting in the soft tissues outside the humeral head. We can use ultrasound. There's an ultrasound image of that surgery, and you can see the torn tendon, and we can target our treatment, whether by fixation or by needling, to that location. And we can actually get a good result without ever cutting the patient's skin. We just make a puncture, and we can show that. And so we have emphasized building ultrasound guided sports medicine intervention. We're in all these locations around the Philadelphia region, not every day of the week, but you can see 3 of the hub in Center City and South Philadelphia, and then all around the suburbs. And we've opened up this set of procedures and diagnostic imaging to patients who hadn't had it before. So radiology is a hot commodity without question. Diversifying imaging and interventional portfolios is key to keeping radiologists happy and keeping them working. Adding value to the national healthcare system is key to growing the status of radiology. We need to recruit and retain with an eye on quality of life, and we need to place subspecialty radiologists and interventional radiologists where the patients will be, like at this boutique subspecialty surgery center in the Navy Yard in South Philadelphia, the Vincera Institute, where we do PT, physiotherapy, surgery, and ultrasound guided intervention. That's what I've got.
Great. Thanks for that, Adam. My first question is, you talk about personalized medicine being a major impact in this space. How do you see that playing out?
Well, I think the days of patients going from one building to another across a hospital system or a healthcare system, I think those are waning. I think patients want to go to a place where they can see an examiner, a clinician who can examine and try to diagnose a problem, get their imaging, and then get their treatment in the same location. So we think, it's hard. Spine procedures, spine injections, you probably have all heard of those. That's a little more expensive to construct because you need ionizing radiation. You need like a fluoroscopy unit. But these ultrasound units are incredibly portable. In fact, at every NFL game for our home team here in Philadelphia, we have a radiologist on the sideline with a portable ultrasound unit, and we do diagnosis and intervention right there on the sideline and in the locker room. I think you're muted, Hall.
So you talked about reimbursement, shifting the cases to various technologies. Do you see that changing in the near future, or you think that's going to continue as is?
Well, that's a constant battle. And every time there's a new innovation, first we try it, then we prove it works in the medical literature, and years later we get it reimbursed, right? So we have to show our outcomes and present our literature to CMS, and then the payers will follow. It's a constant battle. We are introducing new image-guided interventional codes to CMS every single year. It's usually this time of year, about the time of the meeting of the American College of Radiology, when we go to Congress and we try to get these things reimbursed, and we win some and we lose some. But overall, the trend is toward minimally invasive image-guided intervention.
And what drives it in that direction? Is it a theory of it's a better practice, or it's safer, or is it some other thing that causes it to go that direction?
Well, I think it's a combination of the extreme costs of major surgery and the patient satisfaction scores after a minimally invasive intervention. Patients come in, they don't need any anesthesia, just a little local anesthetic under the skin or some benzocaine spray on the skin. They get treated, and most of the time it works. And when it works, they're very happy. A surgery is a big event.
Well, great. Well, we're out of time at this point. If anybody in the audience has questions, go ahead and put them in the chat box. We can follow up with them afterwards. And with that, we'll pass it back to Bill for our next speaker. Thanks so much,
Thanks,
Adam.
everyone.
Yeah, thank you, Adam. And with the next talk, I want to introduce Dr. Simukayi Mutasa, colleague of mine and an expert on artificial intelligence. So take it away, Simi.
Good afternoon, everyone. So thanks for the introduction, Bill. My name is Dr. Simukayi Mutasa. It's Simukayi Mutasa, but I go by Simi. And I guess to introduce myself, why do I know so much about AI? So I've been programming my entire life. Part of the reason I went into radiology specifically as a specialty was because I felt like it had the most amount of interfacing with computers, which is something that I really loved. And right around the time that, the large scale image recognition challenge started using convolutional neural networks was right around when I was a first year resident. So essentially I dived right in and pretty much spent most of my time doing research in AI. I've published over 30 papers specifically in artificial intelligence, and for the most part, I do all my own coding and things like that. So I definitely have a very deep understanding of this technology. And not just that, but obviously I'm a board certified radiologist. So I think that, that allows me to sort of see the interface of these two things and provide a special insight. So what I'm going to be talking about today is how generative models are going to affect radiology departments in the near future and distant future. And essentially, if we go to the next slide here, so what is a generative model? We've all heard of ChatGPT. That's probably the most famous example. Can you go to the next slide, sir? Yeah, so we've all heard of ChatGPT. That's the most famous example of a generative model. Basically, generative models are trying to generate new data, whereas what we might be used to, what the people here might be used to, are called discriminative models, which are trying to discriminate between different kinds of data. So I tried to illustrate this in this picture here. As a side note, every image you're going to see here was created by an AI program. In fact, some of them, I used one AI model to quote another, or to write the prompt for the image generating model. So on the first slide, those images were so basically I asked ChatGPT to describe itself in a manner that I can then prompt another AI model to generate the image. So that's what ChatGPT thought it looked like, which I thought was interesting. So in this picture here, we're seeing discriminative models on the left and a generative model on the right. So what's happening is that, imagine that red is all the pictures of all the cats in the world, and this is what the data distribution looks like. And then blue are all the pictures of dogs in the world. What discriminating models are trying to do is they're trying to basically find a spot, like a place in this data space that they can draw a line through and say, everything that fits on this side is a dog and everything that fits on that side is a cat. Whereas what discriminative models are trying to do, and I try to illustrate here, is that basically the generative model is trying to understand everything that encompasses exactly what a cat is, and then everything that encompasses what a dog is. And then basically you can ask it to draw me a picture of a cat, and it'll sort of take this data distribution in red and try to generate a new image that's classified as a cat. So it's basically a far more complicated procedure for a neural network to do, which is why, we haven't seen these really amazing, outstanding generative models until now, even though the technology is, 6 years old at this point. So if we go to the next slide, what are the benefits? I think you skipped the slide, sorry. Yeah, so on the next slide, so what are the benefits of these generative models, right? Basically, essentially, these things have become so advanced and so amazing that certain emergent properties are starting to arise with these generative models because of their basic design, which is they want to understand everything that encompasses X, Y, or Z. So for example, ChatGPT, all it tries to do, basically you put in a query and it turns that query into a high dimensional vector. And all it tries to do is predict the next word. And then after it predicts the next word, it uses your query plus that first word to then predict the next word, and so on and so on and so forth. So what Google or OpenAI did is they basically used the entire internet to train this model. So you can imagine that it got pretty smart pretty quickly. Now, be careful about using words like intelligence, et cetera, et cetera. This is just a neural network. It doesn't have any sort of special insight or understanding. It's literally just trying to predict the next best word. So that's actually basically all you need in order to sort of simulate this intelligence. So the benefits is that, knowledge work, automating ideas, right? Knowledge workers such as radiologists, lawyers, et cetera, can spend more time editing than creating things, right? You can imagine like a radiologist where the generative model will generate a report for them, or even just generate an impression. We can just start with that, to where the radiologist can then speed up his workflow by not having to write the impression or so on and so forth. Instead, they can go back and edit them. And it's obviously very important to still be an expert, because a lot of times these models in their current state will hallucinate things that just aren't there. But I don't personally believe that that's a huge barrier in the future, and that behavior is certainly going to improve and get better over time, especially when they start specially training these models. Another benefit is, flatter organization. So what does that mean? So as more tasks become automated, there'll be less need for entry-level workers or people who manually compile or analyze information. There'll be less need for supervisory roles. So basically, it'll flatten the sort of the organizational structure of a company, right? So what people have noticed, for example, is that in software companies, basically, if you start using like ChatGPT, et cetera, it makes the entry-level programmers almost as good as the expert and experienced level programmers, because they're using these tools, right? So it sort of flattens everything. Another thing is that a lot of organizations suffer from what's called a digital dexterity gap, where the workforce is largely unable to keep pace with fast-changing technology. So these AI programs can strip away some of the complexity. They'll use conversational interfaces, natural language processing, et cetera, to lower the barrier of entry for tapping into technology. You can imagine, for example, let's say a radiologist wants to create a website for their business, right? At this point, it's extremely easy to do. You don't even need to hire a programmer. You just ask ChatGPT to create a website and it'll do it for you. So you can imagine sort of fields where this technology is going to be massively disruptive, right? So imagine, for example, in like 5-10 years, and I fully believe in like 5-10 years, we're going to start seeing this. Let's say, you're on Spotify and you log on, Spotify knows your preferences. You say, hey, can you create an album for me using Drake and Eminem's voice and Jay-Z's voice, and just create a happy, fun summer album for me to listen to. And basically the generative model will generate a song for you, like an entire playlist, nothing that's ever been heard before. We're actually already starting to see this. I mean, it's still, obviously right now it's illegal to just sort of co-opt someone else's voice. But if you go online, for example, right now, the most popular summer song is a fake song generated by an AI of Drake rapping. So we're going to see that with music. We're going to see that with even things such as, movies, or if you log on to HBO, you say, oh, I really like Game of Thrones, so please generate a new season of a show in a similar vein to Game of Thrones, right? Education is another area where this is going to be revolutionary, right? You can basically now have a one-on-one instructor. So it's like hiring a personal tutor. And obviously, again, right now the models aren't entirely accurate all the time. So in their current state, I wouldn't trust it to tutor my child. But in a few years, like I said, this stuff is going to get a lot better. All right, so if we go to the next slide, what does this mean for radiology, right? Basically, the stress and workload for radiologists will decrease and their productivity will increase dramatically. So what do I mean by that? Like, imagine all your ICU chest films are going to be automatically read, and the AI will generate a report that you then go back and just double check and make sure it didn't, like, miss anything or hallucinate. Or imagine, screening mammograms, automatic generation of report. Eventually, these things are going to get better and better. And for certain imaging, there have been studies, certain imaging modalities, there have been studies that have shown that artificial intelligence is already performing better than human beings. Again, there are medical legal barriers, which I think are going to be the biggest barriers for radiologists. But you can imagine that, I don't read mammal, for example. I could, but I'm a little bit uncomfortable with it. But if I have an AI model that I know is more accurate than an average mammographer, I can use that in combination with myself to double check things and not only learn from each study using, seeing what the computer has output, but then I can then perhaps cover or read studies or help out with the workflow because I have this tool available. So we will be able to generate faster, more accurate reports. But on the flip side of that, the number of radiologists required to do our jobs will decrease. So as Adam was saying, imaging volumes are increasing, I think it's like 5 to 10% or something yearly. The number of radiologists has stayed stagnant or is even decreasing. And we have a lot of older radiologists that are set to retire coming up. Not only that, but we also have a lot of older Americans who need more imaging. And not only that, is that a lot of states are starting to have independent practice rights, for example. So for like nurses, and studies do show that nurses and PAs order more imaging than physicians do. So all these factors mean that our imaging volumes are just exploding. However, you can imagine if this technology makes you 50-60% faster, which I think is actually a realistic goal for certain studies, then quite literally the organization isn't going to need as much of us, right? And that's for diagnostic imaging. The things that Adam and Bill do, and procedures and things like that, those things aren't going anywhere for a while. We're still going to need human beings doing those and people with expertise in that. I don't really think that procedures are in trouble anytime soon, but I mean, look, at the end of the day, if you have 1,000 CTs to read and you have a group of 10 people and everyone does 100, right? But if everyone can do 200, do you really need to hire 10 people? No, you can just get by with the 5 people using these AI models to help. So they'll do this by, again, speeding the formation of new reports. The AI models will be able to summarize prior reports for you. So right now, like when we open a study that has comparisons, we have to go back, look at the old study, get an understanding of the clinical picture, see what's changed. but you can imagine these generative models basically doing all of that for you and just presenting the most important information for you to be able to read the current study in the context that you're worried about. And it will do this with even clinical histories, right? Like it will be able to dive into the medical chart, generate a summary, because a lot of times, especially in bone and joint imaging, all we get half the time is pain, right? They come in and they get a shoulder MRI and the only history we're provided is pain. And it's like, okay, thanks. That's not super helpful. But these computers will be able to scour the entire EMR and find out exactly what you need to read that shoulder MRI. Also, it'll be able to catch errors on your report for you. Like, for example, you could like if you're reading a CT scan of the pelvis, right? And let's say it's a trans man, but they still have a uterus. A lot of like right now, those situations then become easy things to make mistakes on. Like you'll say, oh, the testicles are fine or something, but the person doesn't actually have any. Or it'll find, women who've had hysterectomies, be able to delete that from your report. Laterality errors, right? Sometimes the text will send over and they'll say it's a left shoulder when it's really a right shoulder. And these models will be able to go in and say, no, this is actually the left shoulder. So it'll catch errors in your report, not just dictation errors, spelling errors, etc., but more higher level errors that people can do. They'll be able to generate these structured reports from free-form dictation. So right now, people will dictate specifically into fields, but you can imagine a situation where you literally just say everything in one giant blurb, and these generative models will be able to take that and put every sentence in the correct place. And PowerScribe can kind of do this already with findings mode, but this will be like that times 10. So you'll be able to even speed up your reading by the fact that you now don't have to, spend time scrolling through fields. It'll be able to generate conclusions and recommendations, from your impression. And then not only that, but these models will be able to take your report and summarize it for the patient using layman's terms, right? And you can even see this right now. Like if you take ChatGPT and you can ask it to explain a very complicated concept, but pretend that it's a 15-year-old surfer dude, it'll explain black holes in the diction and vernacular of a 15-year-old surfer dude, right? So again, taking this to how it applies to radiology is, yeah, it'll be able to summarize these things for patients in ways that they can understand, right? Because a patient might not understand what a supraspinatus anterior leading edge tendon tear is, right? So it'll just say, hey, no, this is exactly what it is. And I think, in about 5-10 years, these things are going to be pretty good, and we're all going to be reading a lot faster because of them. And how that works is going to, what's that going to look like for every radiology department is going to be different, right? Again, you quite frankly will just need less people to do the same amount of work, which for a while it'll balance out just because, as Adam said, the imaging volumes are increasing so quickly. However, I think, if you're looking down the line at like 20, 30 years from now, I mean, this technology has advanced so rapidly in such a short amount of time. And the unfortunate thing for radiologists, for most of us, so for me, I'm purely diagnostic. I don't do procedures. Not only that, but I work fully remotely. So the clinicians never see my face. No patients ever see me, right? People like me are definitely in trouble with this technology, right? Because, I mean, you can imagine, if I'm covering an emergency room shift, before I started this job, what they would have outside readers from a different state or whatever do prelim reports. And then the daytime team would come in and double check those reports, right? So they hired me to cover the emergency room, and that's what I do. But everything I do, if an AI could generate a good prelim report, I basically no longer even need to exist, right? So a job like mine is definitely in jeopardy, and I'm looking at like 15, 20, 30 years down the line. It honestly may not even matter because, a lot of people, and I see this a lot with my programming colleagues, right? They tend to oversimplify exactly what it is other fields do, right? So they'll be like, oh, all you do is look at images and recognize patterns. Well, I mean, yeah, but no, There's a lot more thinking that goes into it. However, there really is no diagnostic radiology thing that we do, in my opinion, that wouldn't one day be able to be done by a computer one day. And again, we're talking 20, 30 years from now, right? So what is the world going to look like? Then, I don't know, because when that happens, to be fair, a lot of fields are going to be in trouble. So, people always point at, okay, when electricity was invented, or when cars were invented, no one needed horses. So blah, 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 but now we needed mechanics. So who knows? Maybe there'll be something that pops up that will allow us to, continue to practice in a different way. But it's definitely going to look much different than it does now.
That's great, Simi. What do you think about this slide here? I think this is your final one. What's your comment on this?
Yeah, so basically that's exactly what I'm talking about. So what this one is saying, this is a slide from Goldman Sachs, is that what percentage of occupations are going to be partially automated by AI in the next sort of 5 to 10 years, right? And we see that basically almost all of them, like 35+%. Some occupations are going to be almost completely gone. And then, of course, there are going to be other things that computers aren't going to be able to do. But I think if you're looking down the line, we're just going to have to sort of reimagine what society is going to be able to deal with this. Certainly before I retire, certainly before I die, by the time I'm like 90, I just think society is going to look completely different, because a lot of the things that knowledge workers do are just not going to be necessarily done by human beings. So what does that look like? Who knows? Universal basic income, perhaps. Something's going to have to happen, because ultimately you can imagine, the really rich people that harness this technology are basically going to become like a different species unless we put in regulations to help combat that.
Great. Very good. Appreciate that, Simi. Thanks so much. We have some great comments for you in the chat box. If you'd like to read those and respond while you're online or afterwards, it's great. With that, I'd like to pass it back to Bill Morrison to talk a little bit more about trace orthopedics as well. Bill?
Thank you. And I'm just going to share my screen here. And let me know when you can see it.
We can see it now.
All right. So I'm going to introduce myself. I'm Bill Morrison, co-founder and medical director of Trace Orthopedics. And my background started in the Air Force. And while I was in the Air Force, I was doing spine injections and had some difficulty with discography and some spine injections. So I developed this steerable needle that's on the market now. And it's actually used mostly now for treatment of pain in pancreatic cancer patients doing celiac plexus blocks. So I'm really happy about that. When I came to Jefferson in 1999, I noticed, a lot of these partial thickness tendon tears, and I had bilateral rotator cuff partial tears myself. Eventually needed them operated on, but for years I went with pain with these partial tears because a lot of surgeons don't want to operate on partial tears. So we do a lot of intervention, as Dr. Zoga suggested, ultrasound guided or other types of intervention, needle-based procedures. And I thought one day when I was doing a biopsy, with a little engineering inside the needle, we can actually treat these partial tears by tacking them back down with a percutaneous anchor. And I drew my attention to gluteus medius tears at the hip because it's a really common problem. In fact, if you see someone kind of limping around outside, they probably have a gluteus medius tear. It's something that's personal to me. My mother has this problem, and she has the gait disturbance that you're seeing here. And this is just a CT of a patient with normal muscles. And here at the hips, you see outlined the gluteus medius and minimus muscles, and they're responsible for letting you stand on one leg. So that's an essential feature of walking. And so if you get atrophy of those muscles, as you see here in this 79-year-old woman, you get gait disturbance and you get the weakness and problems that you saw there in that patient. And this is a major risk factor for falls. So we see hip fractures in the older population, predominantly related to falls. And we see falls causing other things, including subdural hematomas and other things that cause a lot of morbidity and even mortality in the US. And gluteus tears are a major component of this. How prevalent is it? This is a complicated slide, but I'll kind of narrow it down for you here. These tears are extremely common. About 60% of patients over age 70 have these tears, and it increases with age, starting in the 50s. So if you're in your 50s and you're feeling lateral hip pain, chances are you have the early stages of this process. So we are trying to intervene in this early on. It's a huge market, potentially. Just from our own database at Jefferson, we had 12,000 of these. Generally, the average age is around 60. In fact, this is a hot topic in orthopedics, what to do about this, because it's a huge tidal wave of these problems. And surgeons don't necessarily want to do this procedure, repairing these tendons, as their whole practice. These are generally older patients. A lot of them are not great surgical candidates. So we need another solution, and they need a solution as well. So that's why we picked gluteus tears as our first indication. In addition, our surgeons have come to us and said, can you do this during our surgeries? And I said, of course, we can do this through a scope, or you can watch the placement with your scope. For instance, this patient came in after a total hip replacement with sudden onset of lateral hip pain and difficulty walking. And what happened here is that the gluteus medius completely pulled off from the insertion site. And this, unfortunately, is counted as a complication of the surgery. When we realized it's probably just the natural history of tears, as we saw on the previous slide. So the surgeons I work with are interested in doing this procedure, tacking them down during their hip replacement surgeries. And we've had interest from other surgeons tacking other tendons down as an adjunct to their surgical procedures. So how did this start? I started in my garage, as most things do, with Home Depot stuff. This is a coil from a pen, actually, that I took out, and this is sharpened. And I made this little screw and tried it out on some meat samples, and it worked really well. So went ahead with the prototype concept and started a company along with Adam Greenspan. And this is the outcome of our first prototype: self-drilling, self-tapping screw with this coil that acts as an expandable washer, and it fits inside a 10-gauge needle. So here's work I did on cadaver hips. On the left, you see the preoperative cadaver with the gluteus medius tendon pulled away from the bone, kind of like a bed sheet off a bed. And here on the right, I tacked it down with the implant. You see on MRI, it's not much artifact. It's stainless steel. And here on CT, virtually no artifact. And the tendon is tacked down onto its anatomic footprint. This actually gives a better force profile than standard suture anchors. And suture anchors have a suture here and an anchor, which is pre-drilled and then pushed in like a drywall screw. And you can imagine the suture part pulls the tendon down with a force profile that's very much like carrying a heavy bag with a very thin strap. So it can cut through the tendon over time, it can cause necrosis, it can cause failure, or it can detach. So our force profile is actually much better than that, distributing the forces across the surface, in addition to pulling the tendon down into the footprint like its natural connection. And here the coil actually provides tremendous strength. We've done instron testing, we've done destructive testing in a sheet model. And here's the sheet model being tested and actually withstood 3,000 newtons of force, which is 674 pounds, which is the equivalent you see on the right there. So it's actually performs actually better than suture anchors in this scenario. It could be placed with various guidance options, either by interventional radiologists, physical medicine rehabilitation doctors, anybody facile with any of these imaging modalities or localization techniques. It can be used anywhere, and consider it to be a new, better kind of anchor: in the shoulder with rotator cuff, biceps tenodesis, at the hip, as I mentioned, in the groin with core or adductor injuries in pro athletes or high performance athletes, at the ankle, elbow, knee, and even in animals. So with that background, I just want to introduce Adam Greenspan, who'll talk more about the business part. Adam?
Thanks, Bill. I'll pull up my screen here and I'll just continue the conversation about trace ortho. Is that coming through?
Yes.
Excellent. Thank you. So I'm Adam Greenspan, CEO of Trace Orthopedics. We're right at the forefront of a paradigm shift for tendon repair. As you alluded to, Bill, by performing the repairs outside the operating room, cutting the healthcare costs in half compared with surgical cases and shaving months off the recovery time. Essentially expanding the market, delivering repair to patients who otherwise often not referred for surgery. Here's a picture of you. If you remember when the initial proof of concept into human cadaver. Since then, we updated our designs. We have product specifications, and here's a prototype for that we used, and we have additional units for more cadaver labs. We started animal testing, and at Colorado State at the veterinary school. The couple of images here, how we compared to a standard Arthrex suture washer, 3 sheet bilateral comparison, one on each side, and you can see the size profile much more favorable for our units in terms of size and ability to withstand almost 700 pounds of force. And in terms of our assets, we have robust IP, patents issued and pending worldwide on the fastener implant, the delivery system, various improvements, including material compositions and coatings, plus method claims. Bill, I appreciate you allowing me to join as a co-inventor, and all the IP is resident in the company now. For our regulatory path, the Trace tendon fastener is a Class 2 device. So we're going through the 510(k) pathway, which means no clinical trials. We show equivalence to existing products. And in our case, it's going to be an anchor washer system. We've begun our correspondence with FDA, and next we're going to provide results from this sheep pilot test, plus our protocol for an upcoming pivotal study under GLP conditions that will go in our submission package. And this will take us into 2024. We're on track for clearance 12 to 15 months from now. And then our plan is to launch shortly after in Q3 24, so that we're ready to fully activate on day 1 after clearance with the planned alpha launch in gluteus medius at the hip as our beachhead. And we're going to have contractor sales reps and dedicated sales staff. For this first clinical application, we already have commitments from about a dozen interventional hip specialists to be our alpha launch sites, and then another 50 or more lined up for our subsequent expansion phase. And at that point is when we'll start to add clinical applications beyond the gluteus medius, around the hip, and into other areas of the body. Meanwhile, scaling the sales team, calling on orthopedics, plus partnering with international distributors. And at that point, we will be hopefully obtaining reimbursement code unique for the Trace procedure. In the meantime, there are a collection of general codes that are available, and we plan to apply them to cover Trace repairs. This will facilitate early acceptance. Interventional radiologists should be attracted by the surgical rate for these procedures, but also we've heard from orthopedics that there's a strong interest to do these, given that it's such a short procedure time. Our revenue model, it's fairly standard, flows from selling our products, which are single-use, procedure-based, to hospitals and surgical centers. And the company Trace resides at the end of the waterfall among the supplies used for these procedures. The initial average sales price for the main Trace fastener kit is going to be $800. COGS is only $198. Some cases, about half, will use a second preloaded fastener, similar profit margin, which is over 75%. And right now we're forecasting our first revenue in late 2024 from the Gluteus Alpha launch. And with repeat users, adding new users, and then expanding our indications, that'll fuel a jump in procedures and push our annualized revenue up quickly so that by 2025, Trace Orthopedics is profitable, and repairing rotator cuff and Achilles also used as an add-on in the total joint replacements like you were describing earlier, Bill. Just a quick overview of our team. We cover the entire medtech spectrum with dozens of patents issued, products launched, deals executed. I'm a biomedical engineer turned entrepreneur. Dr. Morrison is KOL in the field of musculoskeletal radiology. And our board chair, Paul Janeski, runs a medical device incubator and technology broker, Hatch Medical, and is an active angel investor and brings over 30 years in device sales and management execution. We have an all-star roster of scientific advisors and medical advisors. You mentioned Dr. Myers earlier. Dr. Hornstein has also provided valuable insight to us. And next, we're going to be bringing on a VP of R&D, a clinical lead, a VP of sales and marketing after we close our current financing round. It's open now. So it's a $1.5 million capital raise, and it's being led by an angel group known as Kretsu Forum in the Mid-Atlantic region. They have chapters all over the world, and the Mid-Atlantic region also is affiliated with the Southeast region, and our pre-money valuation is $4.5 million. We are using a term sheet that was negotiated with the Kretsu Forum, and it's fairly investor friendly deal. And right now we've subscribed over $750,000. We have another 200K in commitments, and we're within 600K of closing out the entire round. There's warrants attached to the investment, and I'm happy to discuss further offline with anyone who's interested. Our goal is to achieve a premium exit, monetizing our intellectual property by licensing to a strategic partner or through an outright acquisition. And we're projecting a return on investment of between 5 and 16x over an 18 to 48 month period. And I see 4 value inflecting milestones along our exit path: getting FDA clearance, and then after a successful alpha launch, the usual target is 100 cases. And at that point, there is a strong likelihood of a high value license or an early acquisition. If not, then we'll expand our indications, introduce product improvements such as surface coatings and absorbable compositions. And at that point, we're intending to fill out our senior management team and our board to drive Trace to an exit target nearing $150 million. And that's based on some of the handsome revenue multiples that are in the deal comps that we're seeing right now. And have a few of these up here now. And Trace Orthopedics is pioneering image-guided fixation. And I thank everybody for your interest and attention. Happy to take a few questions here, especially while we have Dr. Morrison online.
I have my first question, which is how much change does this require for the physician in doing it? Is it the same or different? And how different is it?
Yeah,
Bill,
Bill. Yes, it's very similar to what we currently do. So it doesn't take the interventional radiologist out of their comfort zone. Right now, we're doing needle-based procedures, dry needling, PRP, prolotherapy, things like that. And this is just one extra step. For the surgeon, it actually makes it a lot easier. Whereas typical suture anchors that are placed via arthroscopy, it takes like 20 steps. This is really like one step.
Right. The next question was, how do you remove this device?
It doesn't get removed like most orthopedic implants. It stays in, just like the suture anchors I have in my shoulder, keeping my cuff in place.
And the next question is reimbursement. How do you see that going in the future? Will it increase, decrease, or stay the same, depending upon the de novo?
Well, the great thing about this right now is that there are current procedure codes for tendon repair around the body. So we can apply those codes. And that's the same model that companies like 10X have used and Sonex. They apply the surgical codes. So we're going to do that and do a reimbursement study in our initial test research.
Great. We did put out a poll for those in the audience. If you could go and fill it out with your thoughts there. Love to get your feedback on interest and otherwise. I want to go ahead and at this point, close it out and pass it back over to Bill for closing thoughts on Trace Ortho and the presentation today.
Yeah, and as Dr. Mutasa suggested, AI is going to be a destructive technology. As Dr. Zoga suggested, one thing that is probably not going to be taken over by AI in the near future are procedures. And the wave of medical care really is centered on minimally invasive procedures. And that's true all around the world. Due to cost savings, volume, and limited resources, minimally invasive procedures are how things are going to go. And I cannot envision a future 10, 20 years down the road where we're not treating partial thickness tendon tears percutaneously. So this is the only option on the market for this type of thing. And we are going to enter that space.
Great. I want to thank Bill for coming today, Adam Greenspan for your presentation on the business side of it. I'd like to thank Adam Zoga for his presentation on the Department of the Future for Radiology. It was a great session. And then Simukayi, thank you so much for your generative AI. A lot of great comments about generative AI tools that are out there. Seems like you got quite a fan club there with it. With that, guys, we'll go ahead and wrap up today. Thanks, everybody. In the chat box are some key links there for Trace, the automation and the documents to review. We'll follow up everybody to make follow-up introductions afterwards. But with that, we're at the end of our hour and want to go ahead and thank people, and we're going to close it out. Thanks so much.
Thank you.
Thanks, everybody.